Hi everyone, thank you for coming to this session. Today we'll talk about NFV MANO and how to implement it in a fully open manner. So actually cheating a little bit, it's not your typical vBrownbag talk because it's going to be 2 talks combined into one. So we're going to have 30 minutes together. And I'm Sivan Barzily, the Director of Product for Cloudify from Gigaspaces. We're based in Israel. We actually have a booth here in the summit, so I'll talk a little bit about that later. And let's start. So I'm sure most of you know what I mean when I say NFV, but just to recap, we're talking about a vision. Taking network architecture to the next level. So moving it from network appliances that really reside on very dedicatedly built hardware into the cloud, running them in a virtualized manner and running with IT virtualization related technologies. So it sounds simple, right? Well, as you probably know, it isn't so simple. It's actually very hard to implement. And the reason is that VNFs, so the network functions that we're talking about, are typically very, very complex. They weren't built for the cloud. They weren't natively designed to run in this hardware agnostic environment. And so if we're looking at taking an architecture of a network function and then moving it to an actual deployment running in any cloud environment, it's not an easy thing to do. And because of that, MANO, the management and orchestration in NFV, is very, very critical to the successful deployment of NFV. When I say MANO, I'm talking about, as said, the management and orchestration stack. Specifically, if we look from the bottom up, this is the virtualized infrastructure manager. OpenStack would be a good example here. The VNF manager, so the ability to manage that network function in the cloud environment, and on top of it, an NFV orchestrator that ties the environment together. So if we looked before at what the mission statement of NFV is, we've mentioned the ability to take those IT virtualization-related technologies into the network. But why stop just at the technology itself? Why not take the web-scale best practices from that IT space, from the enterprise world, and actually move them to the telecommunications space? So we believe there's no good reason not to do it, on the contrary. And so we've implemented with Cloudify a product that's actually a fully open implementation for NFV MANO. And I'd like to just share how we did that. So what is Cloudify? Cloudify, as mentioned, it's a major part of the MANO stack. Specifically, it is the NFV orchestrator and the VNF manager, providing a generic VNF manager to that end. And we call Cloudify a pure play MANO. The reason we call it pure play is because it's a product that's designed to be technology agnostic. So Gigaspaces, the company that's behind Cloudify, doesn't produce any applications or any equipment, any cloud management system. What we do is Cloudify, which is an orchestrator. It means that the product was built knowing that we're going to run someone else's application on someone else's cloud. And so it was built in a fully open manner so that any workload can run on top of any cloud environment, which is basically what Cloudify is set out to do. It also means that we don't mandate anything else inside this software stack, so that if you're running on top of OpenStack, that's great. If you have a multi-VIM environment with OpenStack and potentially VMware and public clouds like AWS or Azure or Google Cloud, that's great too. Cloudify can handle that. It can fit into any architecture, so whether you're running with an SDN controller by any vendor, really, if you have network chains that are service chains that are comprised of different network elements by different vendors, again, something that the product was built to do. And the ability to do that is because of this openness that I'll talk about. So Cloudify handles the full automation of the service lifecycle, starting with the provisioning of it, the configuration, monitoring, scaling, and healing as needed. And the intention is to actually be able to automate each and every step of the way. So you can have a zero-touch deployment, have everything running and managed for you. The product really enables the best-of-breed approach because of this pure play that I've mentioned before. So you can choose whatever fits your stack at any of the different levels. And now, after all this great buzz, how do we actually do that? We've worked with the 3 key implementation aspects, and I'll spend some time sharing how those come to be. So first of all, the product is based on an open standard, which is TOSCA. It's providing a vendor-neutral way to model the different network functions and the services so that interoperability and collaboration is actually made possible. The second aspect is open source. So we're here at OpenStack. I don't need to go too deep into why open source is awesome and why this is the way to go. But we do believe that this is the key to drive innovation, accelerate the progress inside the industry, and create a superb quality software. And last but not least, we've looked into the architecture and made sure that this is open as well. So we didn't stop just with the open source and an open standard. An open architecture is really important because if we're looking at the industry that we're at, it's moving really quickly. We know what's happening today. We know what are the favorites when it comes to today's technologies, but we don't exactly know what's going to come up next. We saw the shift towards containers a few years ago, and it's still ongoing. I think if we would have talked about something like OpenStack 5 years ago, especially in the telecommunications space, I don't know if anyone would believe it, that there'd be this great product driven by a community and so on. So the open architecture that enables leveraging new emerging technologies and not tying into anything in particular is, again, something we believe is very crucial. So diving a little deeper into each of those aspects. First of all, open standard. I've mentioned TOSCA. I assume some of you are familiar with it, but TOSCA stands for Topology and Orchestration Specification for Cloud Applications. The standard is around 3 years old, but it keeps evolving, it keeps changing, and the intention is to capture all the operational know-how for an application and for a service inside something called a blueprint. So basically taking everything needed in order to run the application or the network function in a cloud environment and just modeling it so that any orchestrator is capable of automating this entire sequence. The benefits that TOSCA brings are quite significant. So first of all, if we're looking at this famous or infamous Etsy diagram for architecture, TOSCA is just the service descriptor and the VNFD, the VNF descriptor. The advantages that it brings is, first of all, interoperability. We're talking about a standard. So there's a way to model a function in a way that's agnostic to the entire environment and in a way that's understood and something that any product in the stack can actually do something with and, in our case, automate. So this is what helps those different boxes actually communicate and perform together as one architecture. TOSCA also enables portability. So the way that this modeling happens is actually in a way that's agnostic to the environment. So you're going to model the application without necessarily knowing or saying where it's going to be running. So the same model can actually run in different environments, on OpenStack, on VMware, on other environments in the future. So really, you don't necessarily need to know where the application is going to run. And this is a major advantage, which also enables the next benefit, which is a multi-VIM environment. So the same model, because the model abstracts the underlying environment, can run on top of any NFVI, any VIM, any architecture, really. It means it's also reusable. And another interesting benefit, I'll actually move here, is that TOSCA enables you not just to model your application topology, the different components, and so on. It also enables you to model workflows and policies. So you can say how each and every lifecycle operation is expected to be implemented. Okay, how to run installation, how to run configuration, how to run scaling in case there's a change in the workload and you need more resources. All of those can be captured inside this TOSCA model. And you can also capture the policy so that just defining what are the interesting events that can happen in the environment, conditions, and then when certain thresholds are crossed or conditions are met, what are the actions that need to be taken in order to perhaps just heal, for example, any resource that has failed, or scale, as we've mentioned, like a certain threshold has been crossed and you want to perform scaling. So all of those can be defined in a policy-based manner. We think there's a lot of great benefits to TOSCA, but we do understand that not everyone is necessarily familiar with the TOSCA syntax or would like to dive deep enough to write those TOSCA models. So with Cloudify, we've actually come up with a tool called a composer, which allows you to model the application in a very simple web-based tool. You can just see it here. You can model the topology, then configure the different properties, lifecycle events, so on. Eventually, the TOSCA code, will be generated automatically by this composer. So you can get all the benefits of TOSCA without necessarily having to understand the syntax or know it, and the modeling becomes much easier. So that was the open standard. Now, next in our list of openness is an open architecture. So I've mentioned briefly why we believe this is important, but I think the example of the architecture itself is going to probably make it much more easy to grasp. So the way we've architected Cloudify is, as said, in a way that enables you to leverage existing technologies while also building for future technologies that you're not necessarily even aware of yet. And the way it happens is because we have the basic core components of the product, and then whenever we need to understand another environment, another system integrated with Cloudify and enable workflows to run there, all we need to do is just add another plugin. So if we're talking about the Vim layer, we have a plugin to OpenStack, a plugin to VMware, AWS, Azure, Google Cloud, and so on. But it doesn't stop there. Each little purple dot you see on this drawing actually stands for a plugin towards external components that the product can integrate with. So if we're talking about a third-party VNF manager, for example, this is something that we can integrate with via another plugin. SDN controller, same thing. Plugins can go that way. Integration with different service assurance tools, different monitoring environments, and so on are made possible with the specific architecture. And perhaps an easier way to view it is this. So you can get the core orchestration capabilities from Cloudify as a product, but then whenever you need to work with a new technology, this is something that's enabled via those plugins. So I've mentioned that Cloudify can automate each and every aspect of lifecycle management. So if we look, for example, to the right, you can see some plugins that we have towards configuration management tools. Let's say your organization already works with Chef or Puppet or Ansible and so on for configuration management. Well, Cloudify can actually leverage those tools and this knowledge base and say that the configuration aspect of the application will be done with those. We have plugins towards them, so it's not a problem. If there's another tool that you're using and hasn't necessarily been implemented into Cloudify yet, it's just a matter of writing an additional plugin, some Python code, and that's it. It's becoming part of what Cloudify can support. I've got this far without mentioning containers, or I have just once, so I'll touch on that point again. As I've mentioned before, the intention is to actually be able to run any workload on top of any cloud. And workloads can be of different architectures. We know that in the telecommunication space, we're kind of coming from an architecture that's not necessarily cloud-friendly, but we do see a shift towards microservices and the ability to actually model applications and workloads with containers. So to that end, we've extended Cloudify, and it includes built-in plugins for Docker and for Kubernetes, so that even if your application is with containers, it's very easy to model it in Cloudify and have Cloudify automate the entire lifecycle. And one of the advantages is you can actually do hybrid management, I call it, for workloads that are container-based or that are VM-based or both. So just another advantage here. As mentioned, plugins can be towards monitoring tools as well. I've mentioned some IS environments, and basically this is how we believe we can enable future technologies, because whatever comes, all we need to do is add another plugin, and we get there. So last but not least, in terms of openness, is open source. Again, we're here at the OpenStack Summit, so we all know the importance of being open source, but I'll just touch on that point. So the Cloudify product is completely open source. The code is available in GitHub. You can actually go to our website, download it, and start playing around with it quite easily. But aside from just being open, it also means that this is an extensible code base. And so if there are any specific use cases that you have in mind that weren't necessarily natively built into the product as it was, it's very easy to extend it. I've mentioned those plugins. We actually have a community, and we see that people are writing plugins themselves as well whenever they need to add more technology to the stack that hasn't necessarily been implemented in Cloudify yet. So this is just one more benefit here of the open source code. And of course, you can know that you're not locking in with any vendor. This is very, very new in the telecommunications space. So the ability to actually not have to buy a full software stack from any of the big vendors, mandating exactly how everything is supposed to look, and kind of having a lot of control over the service operators. So this is something we're trying to change, and Cloudify being open source is helping in getting there. And just maybe to add another angle to open source. So we believe that open source is not just something that we do with our product. We also really believe in the open source community and in those open source products. So our architecture and the tools that we use are open source as well, as you can see. The ability to reuse existing components brings two major benefits. First of all, it means that we can focus on our value add. We don't need to reinvent any wheel. We make sure that we use tools that exist and do what they do best, and we can just focus on what we know how to do, which is orchestration. The second point is that we can leverage best practices and the best tooling that are out there. You can see from this picture, Elasticsearch and InfluxDB and Logstash and RabbitMQ. So all of these best practices can actually be kept, leveraged, and again, just enhanced with additional code that bring this orchestration to life. So I don't know if you remember the title of today's session, but it actually included a reference to OPNFV and the virtualization use case, and I'll talk about that for a little bit. So I think this is an interesting slide to me, actually, one of my favorites, because we got to see it in an OPNFV conference. So oddly enough, we attended an OPNFV conference last year, and we see, on stage someone presenting Cloudify. We weren't even aware of that. And what we've discovered is that the OPNFV functional testing team is actually using Cloudify to test the deployment of virtualization by Clearwater. So Clearwater, another open source product providing virtualization, so somewhat like a call center. And the OPNFV team were looking for a way to deploy it automatically, but not just stop at the deployment itself, but also look at each and every other aspect of lifecycle management. So day one and day two operations, like monitoring, like understanding when additional workload has been started, and then potentially driving scaling events automatically, monitoring, healing, and corrective measures as needed, and so on. And the OPNFV team, the functional testing team at OPNFV, found Cloudify to be the right tool to actually deploy virtualization with, so that they can automate those different aspects of lifecycle management. So this is for me, pretty cool because it doesn't just show the product and the fact that it can do what I hopefully just shared with you for the last 20 minutes that it can do. But it's a little more than that. It just shows that openness, or true openness as we call it, is something that can actually increase adoption inside the industry and can actually advance it further in a seamless manner, because it was just as easy as downloading a product from the internet, installing it, working with it. Documentation is out there, means it's really easy to work with it. You don't necessarily need the support of whatever vendor is behind it. And you can just progress much faster getting to your goals. In this case, full automation of a somewhat complex system, again, IMS. The code is out there. It's all in GitHub. The example is public, of course. And this would usually be the demo time. But turns out vBrownbag uses a very specific computer, and I need a VPN for my demo. So instead, I encourage you to come by the Cloudify booth. It's C20. And if you'd like to see the demo, it's running there. So really demonstrating the provisioning of that Clearwater virtual IMS on top of an OpenStack environment, as promised. And before I finish this session, just one thing that we always say in Cloudify. The only constant is change. So we know that we don't know a lot, right? The future is coming. We're not exactly sure what technologies are gonna be popular, what's going to emerge. And we believe in building a product that's ready for that. So not something that's just strong enough today, but also a product that can adapt and evolve as the industry evolves. And we know that's quite quick. And so this is what we've done with Cloudify. And those 3 pillars of openness is how we believe we can get there into a fully adaptable product that's capable of taking you to the future. So that's it. Any questions? Great, so thanks again for your time. As said, come visit us at booth C20. Thank you.